Hello everyone, in this video we are going to solve 707 problem of Leetcode, that is design a linked list. In this video we are going to design a zeroth index linked list. So for starting with, to design any dynamic structure, whether it is a linked list or a tree, we have to design first the node structure. So here we are designing node structure in the linked list. In this node structure we will have two things. One will be the value and another will be the next pointer. The value will be of type int and the next pointer will be of a type node star. Okay, and here this is a structure for a linked list itself, denoting whole linked list. So every linked list is denoted by head pointer, so we'll define a head pointer in it. This is also type of star node. This is a constructor in which we are going to define the linked list. So in every linked list we start a constructor by defining a nil head. So we'll even do this at so here we are going to design next is the get. We are given the index and we have to return the value at that index. So let's start with traversing with the head. So this head will contain the zeroth index value. Now let's find out the index we want. I less than equals to I less than index, and we have to even look that if that index does not exist, then the temp will become null in between, and this in this case we have to return a -1 I plus plus. Here we can do temp is equal to temp dot next, and if temp is equal to nil, return -1. Yeah, return temp dot value. This will return the value at the index what we want. The next function is addAtHead. So what we have to do, we have to add a node at the head of the linked list. Means now the new head will be produced, and this head will be replaced by the old head. So let's do. The first thing, we have to add node at any index in the linked list. We have to create the node itself. So let's start with creating the node. So we have created a node. Let's update the value of the node. And now we are going to add this in front of head. That means this node's next will be the current head, and the next head, now the new head will be this node. Now what we have to do, we have to add at the tail of the linked list. So what we are going to do, the thing I have as a first told that at anywhere we have to add a node, first we have to create the node. So we will create the node. Now we'll assign the value to it. As this is a link Golang, the every value which we is not assigned is assigned by its 0 value. So next we'll be having the null in it. So we'll add value. Now temp, we will again create one new variable to traverse the linked list till its last node. This will be this dot head. Now what we can do, if the linked list is empty, then we have to add this node in the linked list and return. So what this dot head, linked list is empty, so now linked list will contain this new node and then return. Now linked list is not empty, so we have to traverse till the last node. for temp1 not equal to dot next not equal to null. Why next? Because we have to add the value in its next. So whenever temp1 dot next is null, this is the last node of the linked list, so we are going to traverse that. 1 will be equal to temp1 dot next. This is done. Now we have traversed. Now temp1 dot next will be temp. So we have added the new node at the end of the linked list. Now we have to add new node at the index. So let's start. Okay, so first thing, if the whenever we have to add a node in the linked list at some particular index, so what we have to do, we have to find the node which will be the previous node for this newly added node. So we'll try to do that. But first, yes, if the index is 0, if index is equals to 0, means we have to add a new node before the head. So this will be this dot add at head. It will be value and now return. Okay, but what if now we have to find the node in to which next we have to add new node. Okay, so let's do that. For I equals to 0, I less than index minus 1. So this is very important step. Why we have done index minus 1? Because we have to add to a node to an index, so that node will be having an index when it is attached to a linked list. So as I mentioned, we will have to reach the previous node, so that currently that node is having index as index minus 1. Okay, so we reached the node which will be the previous of this node, newly added node. So now if this temp is equal to null, means the index which we are trying to add is an invalid index, so we will return without adding the node. But if it is a valid index, we will have to add this. So for this, what we have to do, we have to create a new node. Okay, so this new node will be a node pointer. This will have value as value and next as temp dot next. Now what we are going to do, we are going to add this node to the next of temp. So now this node is added. What we do, in short, we first check if index is 0. This means there is no previous node, so we have to add this index at the head. So we add this node at the head and we return back. But we check. Now the head is not node, so we have to traverse to the previous node which will be having index as index minus 1. So we figure out that node. If that node is not present, this means that the index is invalid. We will return without adding a node. But index is valid, so we will create a new node. We'll add the proper value and the next pointer will be the temp pointing next, and now temp dot next will be the new node. Now we'll delete the node at the proper index. So let's try to do this. Now if first thing, if it is an empty linked list, we have to move back ahead as we are. So sorry, if it's equal to nil and return. Okay, but if it is not nil, if index is 0, and what we have to do, we have to move the head to its next. And now we will return back. But in the next case, when it is not even nil linked list, it is not even a 0th index, so we have to traverse till the node which is having index is equals to index minus 1. Okay, so let's do this. So for I equals to 0, I less than index, and temp I less than index minus 1, sorry, and temp not equals to null. And we'll be doing I plus plus here. Okay, so temp is equals to temp dot next. If now we get this temp, we have to every time check that whether we are dealing with a node is whether it exists or not. If it is null, then we will be into the dynamic issue. So first check it. Okay, if temp is null, that is even a previous node doesn't exist or a node we are going to delete doesn't exist, then we'll return back. And if it exists, then we'll delete it. Like we'll just ignore it, like temp dot next is equals to temp dot next dot next. So the node in between will be deleted. So let's try to run this code. So let's try submitting this code. So let's do it. We can see the code is accepted for the test given test case. Let's try to submit it. Yes, so it is submitted successfully. Thank you.